So far we have drawn a big square. That's a plus b on the sides. So it's a plus b squared in area. Now let's twist your heads off a little bit and make triangles. Why would you do that? Okay, so, do you guys all see it?
Yeah.
See the thing I'm trying to point you towards? So there's this blue stuff, right? The blue square in the middle. And there's the green triangles. So what do I know? I know that a plus b squared is the same thing, right, as
B plus X.
the blue stuff plus the green stuff. Yeah? It's all playing along with that. Okay, so now make the labeling choice. That's a good idea. You guys were all seeing it. What's the blue labeling choice that I should be making right now? C. Yeah? You guys see that?
C squared.
Is this side also C if that side is?
Yes.
Yeah, because they're all the same, right? You see that? Those are the same triangle cut out a bunch of times. So how big is the blue stuff?
C squared.
C squared. Yeah. See, I don't know about the green stuff yet, but I do know that a plus b squared is c squared plus whatever the green stuff is. You guys want to think about the green stuff for a second?
C squared plus B squared.
That's what I'm hoping to get out of this, right? You guys all see that I'm hoping to get out of this the Pythagorean theorem. Okay, so how about the green stuff? I just want to think about the green stuff for a second. Green stuff? Let me think about one of those. How about one of those little triangles? There looks like B on the base and A on the altitude. Crazy. So how big is one of these triangles?
A plus B squared.
Good.
Oh, right.
You see this? This thing has area A times B, right? Base, base times altitude over 2, right? So that's one of the green triangles. So all of the green stuff, right, is going to be, how many triangles are there? 4 of them? So 2BA, right? That's B times A over 2 times 4, right? Think about 4 as 2 times 2. There's a onesie that we can drop and we get 2BA. Or 2AB, whatever. You guys cool with that? So I should take that information, stick it back over here. So I'm going to get 2AB. I got my C squared. And I'm going to stop writing in colors here soon. So I got A plus B squared is C squared plus 2AB. Cool? All right, now what?
Expand A plus B.
Yeah, let's expand A plus B squared. So if I expand this, what do I get?
A plus B times A squared plus 2B. B squared. AB.
2AB. You guys see the perfect square trinomial? Or you write 2 of these down and then FOIL it out, right? So in the end here, I get this, right? I got A squared plus 2AB plus B squared. Oh, and then we should subtract 2AB from both sides. And when we subtract 2AB from both sides, we get A squared plus B squared is C squared. And what did this rely on?
Squares.
Yeah, this thing needed to be a square, right? So because this was a right angle, that happened. You see that?
Yes.
So what did I find out? I found out the Pythagorean theorem, right? If you have it, whoops. If you have a triangle, which is right, with A, B, and C labeled thusly, right? C is on the long side, A and B can be whatever, then A squared plus B squared is C squared. Cool? There's a neat little book called, what was that called? It's like Math Without Words or something. It's just a bunch of pictures. This is one of the pictures in it. This is like the classic picture in mathematics. It's just this square cut up with no labels on it. And that's supposed to represent the idea of the Pythagorean theorem. If you go look in math departments at four-year colleges, this is like 80% of the time or something tiled into the floor in the math department. At the undergrad I went to, it was tiled into the floor in the nursing department because they had switched sections of the building. Whatever. Cool?